Okay, so this lesson we're going to do the product to sum formula. I find this is very hard because it was like not in the previous course. It's sort of only designed for the extension 2 students who are using those formulas to understand how to solve some trig identity question or trig equation question. The derived like in the proof of a formula is pretty easy. So basically you have sine a plus b plus sine a minus b, that is the sum, right, is equal to 2 sine a and cosine b. Now the reason for that is because what we can do is we can fully expand the left hand side. So we can expand the left hand side, we'll get a sine a plus b plus sine a minus b, and if we use compound angle formula to expand that, we're going to get this expression plus sine a cosine b minus cosine a sine b. And from here, you can cancel the terms that you don't, they're the same but in the opposite sign, so therefore you can combine like terms, which gives you 2 sine a cosine b. Alright, so that is the proof. So you do have 4 of those formulas here, so that's the first one. The second formula, I'm not going to prove it because it's just going to be the same. The next formula here is going to be sine a plus b minus sine a minus b. That's the formula. And the answer you get will be 2 cosine a sine b. Alright, which is just the opposite to the previous one. Alright, so the next one is what happened to the cosine. So we can have cosine a plus b plus cosine a minus b. And that gives you 2 cosine a cosine b. Again, similar proof you can do. What you can do here is just expand the left hand side using the compound angle formula and then combine like terms, so you should be able to get the answer quite easily. Alright, and the last one is cosine a plus b minus cosine a minus b is equal to minus 2 sine a sine b. Alright, so how do we use this one to actually do the questions? And what do we do with the questions? So I guess for first question here is you need to be able to actually change from the product to the sum. So for example, example 1, you want to convert sine 7x and cosine 4x to a sum of sine functions. You can break that into a sum of a sine function. So maybe it will help you to, solve trig equation later or to prove trig identity later on. Alright, so how do we do it? Well, we basically just use the first formula. Alright, as you can see here, for the first formula, you've got 2 sine a and cosine b, and that's a and b. But we don't have a 2 here, so all we need to do is we sort of like need to add a 2. But before we're adding 2, I just want to add a half. Alright, to make sure that that's in the right format. And so in this case, we've got a equal to 7x and b equals to 4x. So we can simply apply the formula, and the formula tells you you've got sine a plus b, so that's 7x plus 4x, and plus sine a minus b, which is 7x minus 4x. Alright, so from here, so you can get half bracket sine 11x plus sine 3x. So that gives you the answer. So this is again pretty easy. I don't find those questions hard, really hard. I find those one are pretty easy to understand and very easy to understand how to do it, as long as you sort of memorize or you are able to actually use the formula to do the questions. So those should be quite easy to deal with. All right, and for the example 2, I'd like to do something that's slightly harder but still pretty easy to do. So in example 2. The question asks you to show, obviously without using a calculator, that 2 cosine 40 degrees minus cosine 20 degrees minus 2 sine 25 degrees and sine 5 degrees is equal to half bracket square root of 3 plus 1. Alright, so how would you show that? Well, I guess the first step, what you need to do here is starting from the left hand side, and then you start to use the formula, right? That's cos and that's cos. Cos, if you go back to the formula here, we are going to use the third one. You've got 2 cosine A and cosine B. we're going to use that one, all right? And luckily, we've got the 2 right in the front. So all we have to do is just apply the formula, which is cosine A plus B plus cosine A minus B. So we have 2, okay, oops, using a different color. We have cosine A plus B, that will be 60 degrees, and plus cosine A minus B, and that will be cosine 20 degrees. All right, minus, all right, then let's have a look. Well, now we're going to use the last formula, even this time we have to include the negative. So that becomes, all right, so because that negative is going to take with the formula, so that entire thing here will become a positive answer there, all right? And then it will be a cosine A plus B, which is 30 degrees. Okay, and then minus cosine 20 degrees. All right, here's the formula. So once you finish that, you can again cancel the like terms. These 2 can be cancelled and use the special angle tables. Cosine 60 degrees is half. And then cosine 30 degrees is root 3 over 2. So once you finish that, you can actually combine these together to form the answer here. So that's pretty easy to do as well. All right, now I'd like to show you a really hard question, because this question can be really hard, very difficult to prove, the trig identity question especially. So I'd like to just use a question from the textbook. So in example 3, this probably is going to take a lot of space for us to do the calculation. All right, example 3, and it's a show question, all right? So show without a calculator again. So show 8 sine 4 pi over 9 sine 2 pi over 9 and sine pi over 9 equals to square root of 3. All right, so how do we do that? It's a really hard question, all right? I'll start with the left-hand side, of course. So the left-hand side is equal to 8 sine 4 pi on 9 sine 2 pi on 9 sine pi on 9. I guess question like this, unless you've got a previous experience of doing that question, otherwise it will take you ages. I'm talking about like more than an hour to do this question from scratch, right? Because there are so many possibilities that you can do. And if you ask me what is the reason I'm doing that steps here, it's just because I know how to do this question. I've done it before, so I know the strategy behind. Otherwise, it's really hard for students to actually do it. Okay, so the way I do it is I'm going to factorize. I'm going to take the 4 sine pi on 9 outside, and you get 2 sine 4 pi on 9 and sine 2 pi on 9. Okay. All right. Now, if you ask me what's the reason, what is the reason that you are doing these steps here instead of basically why are you taking this one out? Okay, it's kind of hard to explain, right? Because your job is to prove the final answer is equal to square root of 3, and then without using a calculator. So basically, what you want is those angle here must be a special angle. Right now, none of those are special angles. So your idea is try to get a special angle, like 2 pi on 3, like pi on 6, like pi on on 3. Those angles here, because once you know those are special angles, it's much easier for you to do the questions. All right. So if we just apply the formula, negative 2 sine, hope you remember, a sine b, I'm just going to write here, is equal to cos a plus b minus cos a minus b. But if you look at this expression here, we don't have a negative number, right? So what we can do is we can switch them around, so we have a positive answer. So we can actually do a positive here, and then we put a negative and a positive there. And then that means we just move them around, we get a cosine a minus b minus cosine a plus b. So that way it's just easier. We don't have to introduce a negative number. Okay, so that gives us, if we do it this way, it will be cosine a minus b, so that's a, that's b. A minus b will be 2 pi on 9 minus cosine a plus b will be 6 pi on 9, which is 2 pi on 3. Now, 2 pi on 3 is actually a special angle, all right? That is equal to 120 degrees. So 2 pi on 3 is the equivalent to 120 degrees. And 120 degrees is a special angle because cosine 120 degrees is equal to minus half. So that way, as you can see, we kind of like remove one of the tricky ratios, so we only have 2 left because that gives you half. All right, a good success. All right, we've got less trig ratios we can worry about. Now what you need to do is expand. Just keep going. All right, so it'll be 2 sine pi on 9. So what I do is I just times this one to that, so you get this. Okay, and then plus 4 cosine 2 pi on 9 and sine pi on 9. All right, okay, keep going. This looks like it's the formula again, the product. All right, so we need to turn that into the sum. All right, but we need a 2, but we have a 4 here. So what we're going to do is just take the 2 outside. So you have 2 cosine 2 pi on 9, sine pi on 9. All right, now I hope you still remember the formula, and you know, with this one here, let's just go back to the previous one. So we've got cosine and sine, cosine and sine. That was the formula there, which is this one. So that is sine A plus B minus sine A minus B. All right? So, yeah, just keep using those formulas around. All right, so that gives you 2 sine pi on 9 plus 2 bracket. We have sine A plus B, okay? So it'll be 3 pi over 9, which is pi over 3. Minus sine A minus B, which is pi on 9. Okay. All right, now if you look at this, sine pi on 9 plus 2 sine pi on 3 minus 2 sine pi on 9. Luckily, we can just cross these two out because they are not special angles. And then pi on 3 is 60 degrees. So we have square root of 3 over 2 because sine 60 is root 3 over 2, and then that gives you square root of 3, which is the right hand side. All right, so just have a look at how long is the question here. And obviously I know how to do this question because I have done it before, but imagine like you never done a question like this before. How do you know that you're going to combine the first 2 terms together, all right, to use the formula? Because you've got so many options, right? If you think about it, you have this 2 as an option. You can combine this 2. Obviously, you can combine that. You can combine the first one, the last one to do the question. All right, and then the only working possible way to do it is you combine the first 2 terms. But the problem with that is if you haven't done the questions, how do you know you're going to combine the first 2? Well, the answer to that is no, you don't. Okay, it's all about experience. It's all about exposure to the questions. I guess, if you try those questions so many times, you can kind of get some ideas that, if you do some calculations, you might need to find out, I want to get some special angles from this 3, so how do I do it, right? How do I get the special angles? Once I get the special angles, I can simplify, I can remove one of the term, maybe this term disappeared. This is the kind of things you need to think about. I remember when I was a student, this was the extension 2 sort of level questions, and I did try using so many different methods, combining so many different terms, and then eventually there's only one way, working out the answers there. Okay, so I hope you enjoyed the lesson. It is going to be a hard exercise. Definitely ask me a question if you don't know how to do a question there. I can help you. Thank you.